All right, let's get started. Welcome to the session on how to build a successful data lake. My name is Alex Gorlick. I'm the founder CEO of Waterline Data. I've been working on data for a good 30 years at companies like Sybase, and I was the founder of one of the ETL companies called Acta. So I was there for data warehousing when that took off, and been working on data ever since. I believe data can actually help us solve a lot of problems, and data lakes are the latest attempt to do that. A lot of this talk is based on a book I'm writing for O'Reilly called Enterprise Data Lake. So I'm talking to a lot of companies that are building data lakes or have built them, and learning from them best practices, what works, what doesn't, and I'm going to share it with you. I'm also going to weave what Waterline does into this talk because it's a sponsored talk by Waterline, and we actually solve an important missing piece of the puzzle. But by show of hands, how many of you know what a data lake is? Okay, almost everyone. And how many of you actually building a data lake or have built one? Also, about half the room. That's great. And the main reason I hear about why people are building data lakes is to really power data-driven decision making. I mean, everybody by now is convinced that data has the answers if only we can get to them. So the premise is we're going to save data, and when we need it, it's going to be available, and we're going to make those decisions. In some ways, it's very similar to data warehousing. And I was there for the initial days, and that's what we talked about. We're going to warehouse all the data and make decisions later. Instead, data warehouse really became a production system for mostly operational BI and some of decision making. And part of it was the platform, part of it was just how things evolved. So now we have a way to step back and do it again. And there's a lot of confusion. There's a lot of confusion about what a data lake is. So before I start with what a successful data lake looks like, I'm going to talk about what's not a successful data lake or what's not a data lake. On the bottom, we have data swamps, data warehouse offloading. People are talking about data puddles. Data swamp is basically you put a lot of raw data into Hadoop. And when you try to use it, it's very difficult to find. Right? And the whole idea is, again, the whole premise is I'm going to save now for use later, but unless it's been cataloged and could be findable, it's actually not useful. It adds no value. And you see a lot of articles about this. The other problem with the data swamp is people are not comfortable opening it up. Right? If you don't know what you have in there, how do you know it's not sensitive? How can you have people access it? Another often very popular project is data warehouse offloading. Let's take our data warehouse, replatform it on a cheaper, more scalable platform, and everything is fine. The challenges people run into is, the data analysts or the business analysts don't see a lot of value. Right? They're saying, look, I prefer data warehouse. I'm used to it. The queries are more predictable. I know everything about it. I'm getting no value out of this. Because you inherit all the processes, right? The heavy architecture, the ETL, the governance, it still takes 3 months to add a component. Just because you put on a new platform doesn't solve any of those problems. And finally, for data scientists, they still cannot get the raw data. I mean, the term data lake was coined by a Pentaho CTO who basically compared it to natural raw reservoir. He said data marts are like a bottled water, right? It's been processed, it's nice and it's ready to drink, and data lakes are the original raw data that now you can process any way you like. So just to finish on data warehousing, you do get cost savings because the platform is powerful and more cost effective, but you don't get the large value people are looking for. Data puddles are basically small, limited, single-use Hadoop clusters. And challenge is that you have low variety of data and low adoption, right? You might do a project, churn analysis, or some specific analysis by a specific small group. So the use case is focused. Sometimes you do fully automated programs like ETL offloading. Okay, no human is going to touch this. Machines are going to run and process data, which is great. Again, you have a very powerful platform, but you are not letting people make data-driven decisions. We have small user community, the data science sandboxes, or marketing group, some, again, very small group. And you need strong technical skills. This is not for faint at heart. This is for people who know what they're doing. They got their sandbox, and they can go at it. If you want a heavily used data lake, what I found is you need three things. You need the right platform, you need the right data, and you need the right interface. And we'll go through all three of these. Hadoop is actually a beautiful platform for a data lake because you have problems with volume, right? It's massively scalable, so it can handle the volume. We always had, inexpensive storage. What we didn't have is ability to process the data inexpensively, right? So you can put it on tape on some optical storage, but you couldn't process it. With Hadoop, you've got both. You can store it inexpensively, and you can process it at scale. You have variety, right? Because it doesn't enforce a schema. It's schema on read. You can actually store anything. You don't have to worry about normalizing your dimensions, conforming your dimensions, and doing careful data modeling until you're ready to use things. It's also, and this is very important, future-proof, right? If you're thinking about the future, you're saving data for future use, you want to be able to get to that data. If you put your data in Oracle, you can only use for Oracle. If you put it in Cassandra, you can only use for Cassandra. If you put it in Hadoop, you can use the same file using custom MapReduce, using PickScript, using Hive, using Spark. You have basically such a modular architecture that in the future, if there is a cool new project that you must use, it can still get to your file. Your file is still available in its original form and can be used by a variety of different technologies. And of course, platform cost is important, and it's extremely attractive cost structure for Hadoop. Now let's look at the right data. Today, most data in the enterprise is lost. People talk about data exhaust. Only a small portion of data is actually stored. Even data warehouse only has a small portion of all the operational data, much less all the other data, the logs, all the IoT messages, all that today is thrown away or aggregated beyond recognition because there is nowhere to put it and nobody to process it. It's also important to save now for later, right? It's like a piggy bank. You don't know what you're going to use in the future. So you want to save it now so it's available. But you also want the raw data. Think of it as if you're traveling with your piggy bank in different countries, you don't know which currency to put it in. So you want to keep it in the original form until you decide where you want to spend it. So it's important to keep the raw data so data scientists can treat it the way they want to, right? If you have a data warehouse, for example, and you have an income field, and you're loading some data and there are some strings in the income field, your ETL job will probably take them out, make it to the 0 or null. If you're a data scientist, those strings might be very useful. It might say retired. It might say student. If it's retired, you might replace it with an average retirement income for that state. That will give you a much better model than making it 0 or null. So it's actually very important for data scientists to have the original version of the data and treat it for the project that they're working on. The other challenge is, and this is, I'm sure all of you have dealt with it in your experience, data gets hoarded, right? There are two reasons for it. One is data is power, right? If I have my data, I can trade it with other people. The other problem is, if I have to share it with you, I actually have to invest time and money to shape it in the way you ask. You tell me, OK, here's what I want. I have to take my data, write some ETL jobs, and create a data set you can use. And of course, this is Dilbert. Dilbert is ever relevant. So what data lake, what people are doing is frictionless ingestion. OK, just give it to me as is. You don't have to spend any money shaping it or putting it in a certain format. Just give me what you have, right? And this is very powerful on two fronts. You have no excuse not to share as a data owner because it doesn't cost you anything. And as a data lake owner, now you can get a lot more data a lot quicker. You don't have to wait for people to write ETL jobs, have bugs in it, and have all kinds of problems. Switching to the right interface, everybody's been converging to data marketplace for data self-service. You've probably been hearing Amazon for data from any number of vendors, selling actually a very different technology, but the concept makes sense to people, right? I want the catalog, I want to shop for my data sets. And then the other problem is you have to provide data at the right level of expertise. If you want your data lake to be successful, you don't just want 3 data scientists using it. You want the 500 business analysts to go there and find data sets and make decisions. So if you give your business analysts raw data, it's going to be a challenge, right? They don't know what to do. They can't write code to treat it and process it. Very similarly, if you give your data scientist cooked data, right? Data scientists like a chef, they want to do their own recipe, right? You don't want to give them a happy meal and expect them to make, beautiful meal out of that. So you really have to provide data at the right level. You have to give raw data to your data scientists, and you have to give nice, prepared, curated, blessed data to your business analysts. So how do we get there? So first step is you have to organize your lake. Once you're organized, you have to set up for self-service. It's really important. IT is getting out of the business of trying to serve data for people. You really need to set it up so analysts can do their job without having to file IT tickets and wait months and depend on other people. And then you open it up. This kind of canonical representation, usually data gets ingested into the raw, sometimes called landing. There are different names for these, but the function is more or less the same. There is a place where we'll bring all the raw data. From there, some data gets curated, processed, cleansed, and so on, and goes into either Prat or Gold, or people have different names for it, but some area where it's blessed, right? This is where you go if you want a data set that somebody has spent time curating it. You can almost think of it as the warehouse. Yeah, this is your data warehouse equivalent. And then there is a large work area where either by project or by subject, people work with data, right? So this is where your data scientists are going to have a project directory and go crazy and create 300 versions of a file trying to have a model that's stable. And finally, there is sensitive data folders where data is encrypted. Not all data needs to be encrypted, but data that does needs to go into special sensitive area where the access is much more restricted. And each area has its own level of governance. Gartner talks a lot about bimodal IT, where originally we felt that everything should be governed the same way. And it kind of made sense, right? Just because data goes from one system to another, why should it have different levels of governance? Well, through very painful experience, we realized maybe it's not practical. Maybe there should be areas that are heavily governed, and there are areas that are minimal governance, where you go at your own risk, right? There are areas where data scientists will, for example, where it doesn't make sense to govern it because most data will be thrown away. It's kind of bad, failed experiments. So typically, raw landing area, there is minimal governance. You just make sure there's no sensitive data people can access. Gold or curated area gets heavy governance, right? This is where you go for trusted data. This is where you go for your reporting, for anything that people rely on should be heavily governed. You want lineage, you want trusted data, good quality, and so on. Then the work area, again, that's minimal governance. If data scientists or analysts do come up with a good data product, it goes into production area and gets governed. Until then, there is not that much value. And then sensitive zone is the most heavily governed. And different people gravitate to different areas, right? So data engineers mostly work in raw area, creating new data sets. Business analysts mostly work with gold or curated area. And data scientists work in work area and use gold area if they can. And finally, data stewards operate in sensitive data area, making sure nothing bad escapes and used. So to ensure self-service, I'm going to skip data scientist self-service because really the most challenges I see is opening it up to business analysts for self-service. So business analysts usually go through process. They have to find the data set and provision it. They have to prepare it, and then they have to analyze it. The first problem comes with, Hadoop cluster is, it's like a flea market. It's all in there, right? You load it, everything, it's in there. But how do you find it? There's a quote from a telco exec who said, look, we have 100 million fields in our data lake. I mean, how do you find anything? And how do people find it? Traditionally, it's tribal knowledge, right? That you ask somebody, hey, do you know where a good data set is? And they might point you and say, yeah, I used this one last year. You don't know, is that the best data set? Is that even a good data set to begin with? Is there a later data set? It's actually a very painful exercise with or without data lake or Hadoop. It's a problem for data scientists or business analysts, right? Because they can't find data and they can't open each file and study it. It's actually not very practical. All those statistics you hear about 80% being spent on getting data ready, most of it actually is spent looking for data, taking the wrong data set, wasting time on it, realizing it's wrong, looking for another data set, and so on. Data stewards, governance people, they're basically saying, look, if you can't even tell me what you've got, how can you allow access? And then data architects and IT people cannot manually catalog. They can't look at all these millions of fields and figure out what they mean. Manually or otherwise, it's actually, they don't actually know for the most part. So instead, imagine if you could shop on Amazon. If you can have a catalog of all the data assets, if you can find and understand it easily and provision it. So at Waterline, that's what we try to solve this problem. We crawl the cluster, we catalog it, we try to infer the meaning of every field, try to help crowdsource what the fields mean, and then propagate using automation. And then we provision it as Hive tables or into other products like Trifecta, for example. So going back, so what you have to do is you have to crowdsource metadata. You can't, there's nobody in the company who knows everything. But there is probably somebody who knows something. So you need to crowdsource and get those people to contribute their knowledge. And you need to do it in a way that doesn't require them to do altruistic work, but we try to do it as part of their process. So as they're working with data sets, they annotate them, they take notes. Because they're not going to remember what 300 fields mean. So as they take notes, you want to make it available to everybody. Once you institutionalize this tribal knowledge, you need to automate, right? You're not going to get every single data set curated, especially since the whole premise of a data lake is you are saving data that hasn't been used before. If it hasn't been used before, who is going to worry about curating it? Then you have to establish trust, right? You have to tell people who curated it. You have to show them lineage, right? How do you know as an analyst if you can use a data set? You need to know where it came from. You need to know the quality, and you need to make sure it's governed properly. Accessing and provisioning, I touched on this before. So traditionally, what we do in the enterprise, right, we take the data and figure out for every user what they should have access to. And for every new data set, who should have access to that data set. The problem becomes, first of all, we have to invest into understanding and de-identifying all the sensitive data. And then we have to keep track of all these people, and every time there's a new data set, go through elaborate negotiations of who should have what. What I'm seeing people do now is much more agile self-service method, where they have a catalog, it's a metadata catalog, and when people request access, that's when they go and analyze the data set, see if there's sensitive data, and decide whether somebody should have access, how long they should have access, what part of a data set they should have access to. So the idea is, instead of doing everything up front and investing a lot of time into ingesting and processing data, do it on demand. When somebody needs something, then you invest time into making sure it's appropriate. We talked about self-service interface. Again, people seem to gravitate to Amazon-like interface with facets and search. Once you found the right data set, you have to prepare it for analytics. You have to clean it, right? Remove bad data, fill in missing values, convert to common units of measure. You have to shape it, right? You have to combine, concatenate, aggregate. There's a lot of different things people do to make data usable. Blend it from multiple sources. Again, one of the big use cases for a data lake, you're bringing data from places that haven't been combined before. So figuring out how to join and combine data is important. So there are a lot of great tools for this. I'm not going to go through all of them. Some BI tools actually have some of the capabilities. And SQL and scripting languages are very frequently used. On data analysis, there are just so many wonderful self-service BI tools. I mean, Tableau, Qlik, there's a lot of them. And Gartner has a quadrant which tells you it's kind of a mature enough market where there's a lot of entries, and you can learn all about it. I feel that data analysis part, the self-service been the leader, right? People started using Tableau and Qlik before there were data lakes. And people got behind this. We want to do it ourselves and do self-service BI. Data prep tools came along because most data sets might not have been usable as is. And then the catalogs are following because it's not good enough to work with the data. You have to find the data set in the first place. So I feel like it's all being pulled through self-service BI from the analyst down to IT. So successful data lake, you need the right platform, Hadoop. You need the right data. Usually it's most of the data you think you might have analyzed, data exhaust. And you need the right interface, the right catalog, the right data prep tools, and the right BI tools. Just a little more about Waterline. What Waterline does is sits between ingestion and the self-service analytics tools. And we catalog, find, and understand and collaborate, let people understand and collaborate, and we provision the data. There are 3 T's we talk about: time to value, tribal knowledge sharing, and trust. So we try to bring all 3 to let analysts use the data lakes. So a lot of nice quotes from everybody from Wall Street Journal to Gartner who recognize how big this problem is and how important it is to have an automated solution. Lots of nice large customers in many different verticals. And we run natively on Hadoop. We realized early on that we need a massively scalable platform to be able to catalog all the data in the enterprise. So we run on top of Hadoop distributions and Amazon S3. We integrate with projects like Apache Atlas. There will, in fact, be a demo on Thursday, I believe, with Waterline and Apache Atlas. And we integrate with business glossaries and all the other tooling you have. This touches a little more on Atlas integration and Ranger. Basically, a lot of the new policies in Atlas are based on tags. But where do tags come from? So either you have to manually tag your data, or you have to use automated tagging tools like Waterline to automatically find sensitive data, propagate policy numbers and account numbers and social security numbers and all the other sensitive data. Data stewardship for curating tags is there between the two products. And finally, the self-service data catalog will leverage Ranger and Atlas and the permission scheme you have to only show people the assets they have rights to see. So with that, please come to our booth if you're interested in more details about the product, as well as to the Atlas session at 4 p.m. on Thursday. With that, I'd like to open it for questions. Thank you. Questions? Yes.
Oliver, it's Peter Evans from Dell. Spoke to you like a couple of weeks ago.
Hi.
Just a quick one. When you're talking about auto-generating tags, is that based on your tribal knowledge and the way your tribal knowledge system works?
Yes. So what happens is as subject matter experts work with files. Let's say I'm an insurance claims subject matter expert. I'm going to take files that have to do with claims and say, oh, this field is policy number, this field is claim type, this field is payout. Then the engine takes that information, finds all the other policy numbers in the cluster, all the other claim types, and so on. So we'll leverage the tribal knowledge, crowdsource it, leverage it, and automate the propagation. Thanks. Other questions? Yes. Question, biggest challenge with building a data lake. I think the biggest challenge that I've seen where people get stuck is onboarding business analysts. I think ingesting data is kind of straightforward. We have nice tools, ETL tools, Scoop. Replacing data warehouse is also kind of, okay, we know we move some reports, some ETL. When they run into challenges is adding value to business analysts to come to a data lake. Because if all they do is have the same data they had on data warehouse only in Hadoop, that's not very interesting. If they have new data, then they have to have a way of using it. And Hadoop is a file system, right? They can't go and do a less minus L. They can't write code. They can't parse data. So making it consumable to business analysts seems to be where most people get stuck. There's a question.
Yeah, in the AWS ecosystem, do you suggest that we use EMR and S3?
I see a lot of people using S3 and EMR in AWS because, S3, because again, you don't know how often you'll use the data, how much. So S3 is a cost-effective storage. And then EMR lets you scale, on demand ephemerally. Question.
There are a lot of proprietary tools, either by big vendors that are starting to come into this space. And Informatica has its own metadata, IBM has its own metadata tools, and so on and so forth. How do you see that ecosystem? First, from an interoperation perspective, whatever metadata they're capturing, how do you get access to that? And B, how do you interact with them from opening your metadata to those tools? Because some of the enterprises are investing in those tools.
Okay, by the way, I'm sorry, I should be repeating question. Can you guys hear the questions in the back? No, okay. You should have told me sooner. But the question is, the traditional vendors like Informatica and IBM are developing tools, metadata tools, and they already have a mature ecosystem of metadata tools. How do you supplement them and how are you different? So first, I'm a former IBM and former Informatica person, so just in the interest of full disclosure. Those tools were developed for programmers. So the big difference is those tools were developed for developers to create value for the analysts. And what the modern tools are doing, tools like Trifecta and Paxata for data prep, tools like Waterline for cataloging, is the idea is for analysts to use it themselves through self-service. So the big difference is this automation and crowdsourcing is the difference because that's how analysts like to work. We do interface, we have REST API, so we can interface with those tools. If there's a business glossary, we can import it and use it as tags that analysts can use. But generally, I think the big difference is the focus on self-service versus the focus on programmers who are going to provide functionality.
So how do you identify all the metadata information unless you do a data analysis? How do you,
So
how do you create the metadata?
the question is how do we identify metadata unless we do data analysis? We do data analysis. We parse and profile every single file and every single field. And then as people are tagging those fields, or as we're importing metadata for those fields, we look at that and we have a discovery engine that says, look, if this field with this signature is a policy number, for example, then all these other fields with certain confidence level should be policy numbers as well. So when the analyst looks for a policy number, we show them not only the field that was tagged by somebody, but all the other possible fields. And then the analyst can curate, say, yeah, you're right, it is a policy number, no, it's not. And we learn from that and we improve our tagging. So, but it's really based on the content, on formats, on content, on all kinds of, we have a lot of different rules we use.
I think my question is like,
Okay.
there's two approaches, like top-down and bottom-up, right? So top-down, like some analyst creates all this business metadata, and then we let data process it. The bottom-up, where first I land the data, then my processing engine can go parse the data, get the value of it.
Right.
I would like to know where does this tool stands?
This tool does it bottom up from, so it's bottom up for analysts. I'm sorry, let me repeat the question. So the question is there are two approaches. Top down, where you define your glossary, your metadata, business metadata, and then the data comes through and gets assigned some metadata. And then bottom up, you have data you ingest, you process all the data, and then how do you then assign metadata to it? So we do it bottom up from the analyst. So as we process the data, we give you a profile, all the information. So as an analyst, you can tag and say, I know what this field is. And then we use that to tag all the other fields. So the premise is somebody knows what data looks like. And as those people work with data, they're going to, for their own purposes, annotate it. Because today they still annotate in their notebooks or in Excel spreadsheets. So we leverage that to propagate the knowledge. Is that making sense? Am I answering? If I'm not answering your question, you're welcome to come. Maybe afterwards we can deep dive. Okay. Any other? Yes.
So what do you advise, how do we handle multi-tenancy data?
Multi-currency?
Multi-tenancy.
Multi-tenancy. I've seen two approaches. One is people like to separate, but they also like to just control it through access privileges. So it depends, right? If you truly have different companies, you need true multi-tenancy. If it's just political, okay, these departments don't want to share, sometimes Ranger or some other mechanism is perfectly adequate. Because the advantage of not separating the cluster into multiple parts is, you can leverage the entire class to do jobs. Hopefully that helps. Yes?
In the industry, do you see more of the data lakes being deployed in the cloud or on-prem?
I think right now I see a lot of on-prem. I think people have, with large S3 farms, they effectively have a data lake. They just didn't call it that. So there are like de facto data lakes in the cloud. Consciously, people seem to be doing it on-prem for the most part. I mean, some customers we're talking to are doing the cloud or growing in the cloud. They start on-prem, grow to a certain size, and say, okay, now we're going to try to grow in the cloud. Longer term, I think it's going to depend on how sensitive data is and whether they can trust it, outside. The question is, are there specific transformations or specific reasons that justify? I think if a lot of data, like IoT data, coming from the cloud, people seem much more comfortable keeping it in the cloud. Like you're getting Twitter feeds or you're getting your own IoT messages. Other than that, there was a recent article by Capital One CIO who said, we're going to go to S3 because Amazon is going to provide better security than we ever can. It's the only one I've seen like that, but if that's a trend, then I think there'll be more. I think there's a big debate about cloud security. It hasn't been broken, so I think people are feeling more and more comfortable, and in fact, a lot of people, have Salesforce in the cloud and trust a lot of their data anyway to the cloud. But I haven't seen mass kind of movement yet. Any other questions? Yes.
Do you have maybe any first step advice for changing a data swamp into a data lake?
Yeah, do I have advice for changing data swamp into a data lake? Well, you need a catalog like that's why we developed the product. We talked to enough people with swamps where they just didn't know where to even start because, again, manually you can't open even 100,000 files and look at them and make sense of them. So it's a little self-serving, but that's the best answer I can give you. Anything? Yes.
So do you suggest any advice about the security of the data in the data lake? What kind of security do you suggest?
So I'm seeing a trend towards sort of not thinking of security up front. Right, so the idea is the analysts, data scientists are going to work on all kinds of data. You can't even think about what they're going to need. So instead of doing security up front, do security on demand. I was talking to Merv Adrian. He used this term so far, security on first access request. So when somebody needs data and they ask for it for the first time, that's the time you can think about, okay, should this person have access? Who should authorize it? Is there sensitive? All that information, it has to be resolved, but why resolve it until somebody needs it? So I see a lot of push to doing it on demand because that's when the budget is there to even spend time on it. So that's what I'm seeing, sort of metadata-only catalogs where, yeah, there are some files everybody can see. There are some files that only owners can see, and the rest is done dynamically.
And do you absolutely suggest keeping the raw data somewhere?
Do I suggest keeping the raw data? I do because from what I've seen is, people always miss it. Because there's always, let's say there was a bug in ETL. Okay, well, you lost the raw data, you can't fix it. Or you realize you wanted a different way, but you have no raw data, so now you're sort of trying to reverse engineer something. I haven't seen it being a problem. Again, maybe there'll be, data lakes are fairly new. So maybe there'll be like a time-based hot medium code where people start archiving it or moving it out after a while. But so far it seemed like the main point of a data lake is you have raw data as well as clean, curated data. Yes. In the back? Oh, time is up. Okay, well, time is up. Thank you very much, everyone.